formal talk, I would like to ask you, do you have this sheet? This one? So I would like to explain something here. And the first one is the names on the block, on each block are the speakers. And for the lunch break, we will have the lunch box, so you can eat it here. And between the break, we have the coffee break. And here, the first day, the opening dinner, and the second day is also with the lunch box. However, we will not allow to eat in this room because this room will be closed at 5 after the sections. And so you can go out with a local student to eat anywhere you think is okay to eat. Okay. And the third day is a banquet. So the banquet will be held nearby here in our hotel. And so I think our student will bring you there, okay? And if you look at this, this one, the sheet here, you have the time slot between 15:45 and 17. We have discussions. The discussions is designed for the student if you have, you would like to present or you have some questions, and you can come out and make discussions. As for the one, there is one on Thursday. Okay, that's very peculiar. You see, it's a Chinese culture. Okay, you know what it is? The Chinese culture is Chinese culture. Okay, okay, and as we have people from Western country and from Western country, if you ask them what's Chinese culture, well, can you answer me? Okay, so even for the local person, don't know what this is. Okay, now I would like to explain this. Okay, what Chinese culture means here. Actually, the one is asked by our director, okay, the vice president of National Taiwan University. He said, okay, we would like to introduce this to the foreign student, and he asked me to be in charge of this section. And then I say, okay, no problem. And I found some problem here, okay, because I don't know what kind of Chinese culture I would like to present here. Generally speaking, Chinese culture may be a rough impression, maybe include a Chinese painting or a calligraph. Or maybe people are more interested in what is called Qi, right? And Tai Chi. And especially maybe I think maybe Tai Chi would be a good topic here, because if I explain this Tai Chi, then if people from Beijing University, he knows that the undergraduate student, they need to take this course. Am I right? Right? They need to take this course in order to graduate. Interesting, right? So what's the reason?
Actually, it's correct because everybody in Peking University, actually not everybody, every boy student, they have to take Tai Chi because they believe it is something connected to the Chinese culture or Chinese, but actually sometimes it is boring because it is obliged, and sometimes people want to choose some other physical exercise courses like ball games, something.
Okay. Okay. He got two answers, right? the first answer is what I want. The second one, the answer is not what I want. It's, let's say, boring. Well, he needs to have patience, okay? But, okay, so I decided maybe you can, if you want, you think it's boring, but only one time, right? For the rest, it's not boring. You can learn a lot. So I decided to present what's called Tai Chi. But the presentation it will be different. I will ask you guys to practice it. Okay? And why I say this? Because in fact, as a matter of fact, I have practiced Tai Chi for more than 40 years. And when I was a student in National Taiwan University, actually my main major, undergraduate student, major was Tai Chi. And I spent maybe sometimes 8 hours a day. Ridiculous. And I'm glad that I graduated from physics department. And so, in fact, the people who initiate this boring program in Beijing University, okay, I'll give you a hierarchy, who he is, okay, and who he is. So, in this slot, I would give you the introduction of what Tai Chi is, maybe Tai Chi sword or Tai Chi chain, and because it's kind of interesting if you understand what it is, okay? Okay, I don't want to spend too much time, and now I'll pass this to the first speaker, our director, and the vice president of National Taiwan University, Professor Ching-Ray. Okay, let's welcome him.
Professor Chang actually is a year senior than me when he in undergraduate. Can you hear me? And he is an expert in Tai Chi boxing. Actually in Taiwan, probably also in China. Actually, if it's a recent movie of the China Tai Chi 103, 123, and that story actually is described, his master, actually, and so he is quite an expert on this. And so you probably, I advise to have one lecture per letter because if they are school, we hope this one can be a school. And so we need some course for the exercise also. And that probably is one of the possibility. But anyway, okay, I think that, I will spend an hour and a half, to give some, some brief idea of the introduction of Spintronics and Topological Insulator, and basic and some potential application. And within an hour and a half, it actually is not easy to cover everything. I try to, do as much as I can. And also, actually, I want to emphasize what is the reason we try to do this. Actually, right now Asia grew quite fast, not only in the economic but also in the science and technology. So we know actually in the Western countries, such as in UK, there's a Russell Group and also Ivy League, and we think probably in Asia we should also have a similar prestigious league. And so we talk with other college of science in the leading university in the Asia, especially in the Great China area. And we agree actually we should try to initiate some kind of the pilot and also initiate the summer school. One of the main reasons for summer school is also just like Professor Fong just mentioned in the very beginning. When I was in my early career, especially for the graduate school, I attend some, summer school and such a golden conference. I do, learn a lot actually for those things, not only by the, academic and the scientific knowledge, but also during that time, I knew a lot of good friends over there and in the early career. So after 20 years, actually you do, have a lot of help for those, people you learn when you are in the younger age. So actually we hope actually we can, get together all the, the good, quality, graduate student and to get together, know each other and get familiar with their expertise and can be a lifetime friend in the future. And that will help a lot. And this one actually is last year I was in Germany in the the summer school, and also quite interesting. And I think we should actually, initiate some kind of the low school actually similar in Asia. And so actually the finally the initial is we try to lead in Asia college and committed to achieve and maintain the high quality research, excellent teaching, the outstanding learning experience. Most of all, College of Science finally should be able to bridge between the business and the possible with the public sector. So initially we discussed with 5 different dean of College of Science for Hong Kong University and the National University of Singapore, Peking University and the Tsinghua University, and also National Taiwan University. All agree we should start to initiate this, and with the help actually of the minds and also the postdoc actually. Finally, actually, this school was initiated right now. Also, the Spintronics, actually, why we choose the subject, actually, of the Spintronics. Actually, Spintronics and Topological Insulator, actually, is right now, is the rising field, actually, not only in the condensed matter of physics side, it's interdisciplinary, and actually, right now, quite a lot of, high energy theory actually also move into here, not only by that, actually quite a lot of knowledge here already move into the industry. I will mention that also later, and they did affect the current state of art semiconductor industry right now. And so actually we also initiated about 2 years ago. We initiated one special purpose journal called Spin, and this is sponsored by the World Scientific. Right now it's the 2nd year of this special journal. Actually, World Scientific is stayed in Singapore. Actually, the board, the owner of this actually is Professor K.K. Park. He is quite supportive for this journal, and we spent about half year to try to organize what we should be the name of this journal, and finally. Stuart Parkin give a very good suggestion. He say the shorter the better, and he say all the good cited journal is very short. At first we try to call the Journal of Spintronics, but he say it's not good. Spin is good, and so later on we just call it Spin. But anyway, actually, after committed to initiate this journal, it turned out to be it's not easy job to do a journal. It's a very difficult job. Anyway, right now it's the 2nd year for this, and we do have quite a lot of different people to help, such as Hideo Ono and in the dilute semiconductor and the Spintronic device, and even Sosen Zhang actually, and for the topological later. Okay, I think I will spend an hour half and try to give you a brief, about history and the background, and also. I myself actually studied in the magnetism actually on the late 80s when I was in UC San Diego. And at that time, actually in 1987 or 88, quite a lot of things happened in the physics field. One major importance in superconductor, and other things actually is the giant magnetic resistance. But anyway, I will mention something that at that time actually the magnetics moved to micromagnetic in the late 80s. Then in the 90s, they changed the name to the narrow magnetic, but similar things. But later on, actually, the Spintronic appeared. Then, in Spintronic, I will choose 3 subjects, actually. I think it's quite important for Spintronic. Is that how you transfer the spin torque, how you generate the spin current, then the most difficult things, how you do the measurement. Because if you want it to be a real device, you need to generate the current, transfer the current. Then you should have some certain way to measure it, and all those things is under intensive study, and also try to make the real device hands out. And just as Professor Chen mentioned, actually, because the spin current idea, the concept appear from here. Then later on, the topological insulator comes out, and right now, quite a lot of people devoted and switch their research, field into the topological insulator because they think it's a good way to achieve the some kind of the quantum computation maybe in the future. So I will also provide some postback and application actually of the Spintronics and the topological insulator and within this talk. Actually, if you go back to see the history of human life, no light, in the world actually, except electric light, what I mean, only 160 years ago. The human life actually changed very fast within the last 200 years. No computer actually 70 years ago. You cannot believe that. You use the computer every day. No biotech actually 40 years ago. And no internet even about 30 years ago, 25 to 30 years ago. When I was in the graduate school in UC San Diego, at that time internet actually appeared and then later on moved. And also internet turns out also thanks for the physicists. Actually the idea was invented because they tried to do some data sharing actually of the CERN, high energy, the experimental data sharing. And nobody knows what will be the new in this century, but we definitely know one possibility is that the Spintronics will definitely hang out, in this century. So actually the Spintronics turns out it also comes from the major discovery in the early 20th century. Actually, in the physics, we have two major things, appear at early 20th century. Actually, it's quantum theories and the relativity. And of course, here we will not mention about the Einstein relativity. But anyway, this one, if you all remember, in the year 2000, year 2005, we have the International Year of Physics. And at that time, actually, we used the 101 power, spell out E equal to NC squared on that one. And they have one very interesting story here. Actually, 101 tower actually was operated on the January of the 2005, and fourth, the April 19th actually is the physics enlightened the world, the activity. So the global networking, they try to collectively use the light to celebrate the International Year of Physics. So then, we have idea, talk to the owner of the 101 tower, say, can you lend the 101 tower to us? I'm the president of the Physics Society of Taiwan at that time. And at that time, she promised, it's a lady actually at that time, she promised, but however, he asked me, you need to get this activity to be ranking the #1 in the world. Otherwise, we will not see each other after this event. But anyway, why we can do that? Because all the 101 tower is empty at that time. They don't leave any space outside. So we can use the whole building. So at first, we proposed the idea, say we want to use the deck to spare the wall in here. She said it's impossible, because we didn't have the design for that. But so actually we use a very brutal force to do that. We turn off the room of light. we first do the computer simulation on the dot, because each window is a dot. So we unplug the room, the light plug, and for the room we don't want. So then we turn on the whole building light, the power, then it will appear. But anyway, 2 weeks before the April of 19 that week, this deck was renting out by a German company. Suddenly we cannot use this one. Then it turned out to be a disaster, because it's already been announced we will do that. So we sent two person to negotiate with the owner of the Germany company. I forgot the company name. It's some kind of medicine company, Pfizer probably. But anyway, so the Germany owner said, why we want to help you? We will lose a lot of money because we asked them to shut down the office after 5 p.m. They don't want to do that. But later on, we gradually, casual talk with them, negotiate with them, and they ask, why you want to do that? He said, we told them we want to celebrate the International Year of Physics. And they said, and also because of the April 19th is the how do you say, the pass away day. Einstein died that day. And that Germany company owner, so happy, say, you are celebrating some Germany physicists. then he said, we definitely will help you for that. So then he asked whole his group move out after 5. But that's actually, because I didn't study the history, I was so surprised why Einstein was the Germany. I saw that he was from other country, but later on I know the reason. The Einstein, when he said something, he said, if later on people find the relativity is the true physics, the Germany will say, I'm Germanist. And the French will say, I'm, what is that? Jewish. And if the relativity is wrong, Germany say, I was Jewish. And French will say, I'm German. But anyway, the resolution in here is not good. Actually, there are still 2 windows, 2 office doesn't shut down. So if you see they have some spot actually on the bottom of 2, that's because of 2 office. Well, German companies still work over there. But anyway, this is not that. But finally, we really, because of this, we really got the ranking first. They issued the European Physics Society issued the ranking actually to Taiwan. Actually, that ranking first for that activity. Yeah, so later on you will see that one of our tower always spelling things on their window because we provide their idea. I forgot to patent that idea. But anyway, for the quantum theory, actually later on in the whole 20th century, they moved from the few body to many body physics, and so actually quite a lot of things cancel out from those things. The solid state system, metal, insulator, superconductor, and magnetism, and also the band theory actually is quite important things later on. And right now we graduate, such as graphene and topological insulator, all kinds of scheme. And yeah, this is the first slide I want to put. What is the future of the spintronic? Actually, spintronic actually is combination right now on the magnetism and also optics and also the charge transfer and also heat, all together, merged together to comes from the spintronic. I will mention about what is exactly meaning for the spintronic, but they need all kind of the knowledge. And also they have the application on the storage and also logical things. And they do already prove actually the industrial market on the classical way of the spin, classical behavior of the spin, such as the Enron spin bar and the device. But for the quantum way of the application of the spin, qubit and other things is still undergoing. Yeah, I will make a very brief actually on the storage things. Actually, that actually is the magnesium come from. Because the reason why magnesium was studied on the late 80s, because actually a lot of storage things, such as your hard disk, and also is on the magnetic. But storage actually you have 4 different ways. But the magnetic is for the high volume and the faster access. Of course, recently flash comes out, but still for large volume, it's not repressible actually for magnetic recording. And especially, you know, right now the website, actually the magnetic recording storage business still keep on going because actually people want not only from the gigabyte, terabyte, petabyte, right now exabyte. Actually, you know, the web actually need a lot of the high density recording, and the magnetic recording cannot be replaced by the semiconductor business. But if you come back to see the history, it's not too long ago, 1938. Actually, people only at that time, AT&T, figure out one way to use the steel, you know, tap to do the magnetic recording. But the IBM, 1956, IBM, RAM, only 5 megabit storage, but need this large things. About, you know, the hard disk actually is 24-inch, and you need to 50 disks to have the 5 megabyte actual storage for this one. But because of the, you know, the study of the physics, actually knowledge improved. If you see here, actually from 1956 to here, it's just like Moore's law, semiconductor Moore's law, because technology is the same, just gradually improve. Only happened in the 1992, suddenly the slope changed. Why the slope changed? Because application of the giant magnetic resistance. Because giant magnetic resistance phenomenon was identified in 1988. And because of the IBM, actually probably mainly from the contribution of Stuart Hawking. So starting in 92, the whole thing is actually slope change. So the new knowledge will change the slope. So sometimes I see the semiconductor industry, you always proud of Moore's law. But because if you have the same slope, which means you are only doing the improving, but not you know, you only do the evolution, but instead of revolution. But in the magnetic recording industry, you see actually the revolution cancels out on the 1992. Right now, actually the goal, the commercial product already can be 800 gigabit per square inch. If you go back to see 5 megabytes actually on the whole machine, but right now you have 800 gigabit per square inch on commercial product. It's amazing, you know, improved within the last 50 years. And all those things comes from the research of the scientists. And also right now, today the goal actually of the commercial product very soon within next 3 years, 1 terabit per square inch. And within the lab demo is the 10 gigabit, 10 terabit per square inch. That's amazing things. So, you know, because of the hard working of the scientists and engineering, you know, this is the storage, you know, price. This window is the paper price. If you use the paper to store the information, and you need this one. Right now, actually, it's much cheaper than that. And so people sometimes say, if every industrial is working as hard as the magnetic storage people, right now the Rolls-Royce should be as cheaper as a car machine, a toy car. And because the price actually reduced quite a lot if you see the last 50 years of storage system. So actually, at that time, when I was graduate student, we are for magnetic, micromagnetic, and the narrowmagnetic. If you see the magnetism, actually you can see the review the system, you know, 19th century, you know, Maxwell equation. So current-induced magnetism, and also Ampere law and the Faraday law, magnetism-induced current. And right now, 20th century, actually, you know, spin orbital interaction can see. And so you have the giant magnetic resistance, tunnel magnetic resistance. Also, right now, actually, 21st century, right now we have the spin torque transfer. Actually, Transrisky and Berger actually proposed this idea. Right now, we can realize this. Also, we can use the spin Hall effect, the inverse spin Hall effect, to become somehow the good source of the spin current. So you have the transfer way and the spin, somehow the spin current generator and the spin current transfer way. So this one actually is quite a mature technology right now. I will explain those things later. And if you go back to the magnetic and spintronic material, actually they also change a lot after 80. Buff material.